In this video, we're going to solve a problem to find the volume of a solid using the integration. So the solid is obtained by rotating this curve, y is equal to the square root of x, around the x-axis. So if you don't have any clue how to, so first of all, we have to draw this curve. So if you don't have any clue about how to draw this, just square both of the parts of this equation. If you square both of the parts, it's going to be y squared is equal to the x. So which is very much similar to the y is equal to the x squared, right? It means like y is equal to the x squared is a parabola. Then y squared is equal to the x, or x is equal to the y squared is a parabola which is lying on the x-axis actually. So we can just draw this. Let's put the coordinates here. Good. So now we're going to draw this. So at the 1, it's going to be 1. So whenever y is equal to the 2, x is equal to the 4. So it's going to be really here. So x is equal to the y squared is going to be roughly this kind of curve, right? But we are given just curve y is equal to the square root of x. So only the upper part of this curve is going to be y is equal to the square root of x. So the lower part actually is going to be y is equal to the minus square root of x, because all the values of the y are negative here. All the values of the y are positive here. So we've got this curve and we have to rotate this curve around the x-axis, and we have to do this from 0 until 1. If you rotate this, actually, we're going to get this kind of solid, right? Which is filled inside, actually. So here as well, some solid. And we can find its volume using the formula. So the volume is equal to the integration of the area of a slice. So whenever we cut this solid at some point x, we've got a slice, and this function a of x is going to give us the volume, the area of the slice. So we have to integrate this from 0 to the 1. So no matter what point we choose on the x-axis, so this function should give us the area, right? So this area or that area and so on. So this should be a of x, and it should depend on the x. So you see, so depending on which point I'm choosing on the x-axis, the area actually is different. So in order to find this, actually, I see that since I obtained the solid by rotating a curve around the x-axis, so the slice is going to be a circle, and the area of a circle is going to be the radius and the square multiplied to the pi. And the radius actually is the height. So if radius of a circle at the point x is going to be the height of this curve, right? So here, for example, if I choose the x, the radius is going to be the y coordinate of this point, right? And here as well, so the y coordinate of this point. And we know that the y coordinate of that point at the point x is going to be a square root of x. For example, if I choose x to be equal to the 1, then the y coordinate is going to be square root of 1, which is equal to the 1 and 1. If the x is equal to the 1 over 2, for example, then the coordinates of this point is going to be 1 over 2 and 1 over square root of 2. I obtained the y by just substituting the x to this curve, right? So in general, the area of a slice is going to be the radius in the square multiplied to the pi r squared. So it's going to be pi multiplied to the radius is the square root of x actually in the square. It's going to be pi x. So if we would like to find a volume, it's going to be square root of, so the integration of the ax, which is pi x, and we have to integrate this from 0 to the 1 with respect to the x. So since pi is a constant, we can take this out from the integration. It's going to be pi multiplied to the integration of the x dx from 0 to the 1. The integration of the x is x squared over 2. So we're going to put the pi multiplied to the x squared over 2. We have to evaluate this at the 0 and 1. If you substitute the 1, it's going to be pi multiplied as a 1 over 2 minus, we have to substitute the 0 instead of x, it's going to be 0 over 2, which is going to be exactly pi over 2. So the volume of the solid is equal to the pi over 2.